All right, so I think I'm recording. Let's take a look at we were looking at skill packet 5 with exponential and logarithmic functions, and in skill 5F we're solving logarithmic equations. You definitely need to know your equations of the properties of logarithms. Um, we have a product rule that says that if, see here, all of these have the same base, they all have a base of e. And rather than writing it log base e, they write it ln, natural logarithm. I'm not exactly sure why. Um, if you really want to, in the beginning, prefer to think of this as log base e of 2 plus log base e of x is equal to log base e of 36. You know, as a beginning student first learning this stuff, that's exactly what I would do. But we have a product rule that says if you have the addition of two logs of the same base, that you can write it as a single logarithm, and that we can write this as log base e of 2 times x. And over here, we have log base e of 36. Well, these logarithms and the exponentials are one-to-one functions. So if these numbers are the same, then these arguments must be the same, and that we have that 2x is equal to 36. The logs do not cancel, but the justification is that it's a one-to-one function, but I know that students are going to describe it like that. So x is equal to 18. Check and make sure that you're not taking the log of 0 or the log of a negative number when you plug 18 into your equation. Everything looks good to me. Let's do another one. Here we have again all the terms are logarithms. All the terms have the same base, so I can use my properties. I have a quotient rule that says if you have the difference of two logarithms, you can write that as a single logarithm, and it'll be a fraction. Quotient, you can think division. And the same thing over here. I have a numerator of 6, a denominator of x plus 4. So now I have, you know, and these coefficients in front of the log have to be 1 for me to apply this one-to-one function idea. Since they're one-to-one, that means this number 3 over x is actually the same number as 6 over x plus 4. So this type of an equation is referred to as a proportion, and one technique to solve proportions is to cross multiply. You can multiply along this diagonal, you can multiply along this diagonal and set their products equal to each other. So we've got 3 times x plus 4 along one diagonal, and we've got 6 times x along the other diagonal. So that's one equation and one unknown. We can use the distributive property and now properties of equality to get the x, you know, by itself. So subtract 3x from both sides. Divide by 3. This is a possible answer. Plug in 4. Hey, I can take the log of 4. That's a positive. I just cannot take the log of a negative number. I cannot take the log of 0. If I plug in 4 on the right-hand side, I get 4 plus 4. Hey, that's positive as well. So I know that this is not extraneous. So I'm going to stop there and do these solutions in pairs. So I hope that helps, and talk to you later.